Right, so I've got this Esprit V8 on the engine stand. Got it orientated over at the moment, so there you can see it's a V8. Got it orientated with the right hand bank upright, because I've been finding out where TDC on cylinder 2 is. I realised I don't need to do that actually, because I now realise that the sensors, or the tabs on the crankshaft damper are aligned at 10 degrees BTDC, and this locking tool that you have to check that cylinder 2 is at BDC actually sets it all up for you. And then the disc that you have from Lotus with all the referencing points for setting the cam belt tensions all aligned to that. But well, I went old school, so I set up a dial gauge, and I've got a rod down on the piston crown on cylinder 2. And it certainly is true, because I just wanted to show you that I found where TDC is, because if I continue to rotate, I'm focusing, I continue to rotate, down it goes again. So you can see, there we go, the piston's going down, and my rod will travel all the way down. So that's how you normally set up camshaft timing. You find where TDC is by going either side on your dial gauge and dividing by 2 and finding the midpoint. Set your dial gauge like this, then you can set up the camshaft timing. But Lotus have this system where you just use this locking pin on the crankshaft, replacing the crankshaft sensor. So I've taken out the crankshaft sensor, the locking pin there. That will fit over the tab on the crankshaft damper when you're at TDC on number 2 cylinder. Right, so I've got the crank at 10 degrees BTDC on cylinder number 2, and it's on a compression stroke, because we can see the lobes on the exhaust cam and the inlet cam are well away from lifting the valves. And now we can see that the locking pin is fully down on that lobe on the crankshaft pulley. And in this position you can double check the cam timing as well. What we've got some tapped holes here, and there are drilled holes actually on each of the 4 camshafts, and that's what you use these tolerance pins for. What I find really useful, to tell that you're definitely on the compression stroke on cylinder 2, and that the pins are anywhere near alignment for these tools, special tools, is to use the optical camera. So here's my optical camera. You might have seen I've been doing some shots down the bores and cleaning out. Well, I've been looking down these alignment pin holes to make sure they're in the right place. But once you've definitely checked that they are, you can then double check by putting each of these special tools, which will only thread all the way down if the cams are definitely timed up correctly. And well, here's all 4 of them. So there we go. So that's what I'm actually doing. I'm just checking over things in preparation for changing the cam timing belts, because although the engine hasn't done any miles, there's a mileage limit and a time limit for these toothed belts. The engine hasn't done any miles, and I have been turning it over periodically over the extensive time it's been in storage, but I'm afraid they're out of time, so they're going to need changing. So I've got the new belts already. Okay, so I've got the engine back in the normal horizontal orientation now. We've got the crank timed up at 10 degrees TDC, and you can see that the locking pin locates straight onto the crankshaft damper there, and all 4 of the camshaft pins are fully home. So in this condition, the timing between the crankshaft and all 4 of the camshafts is preserved, so you can safely take the belts off and replace them, which is what I'm going to be doing. We actually obviously remove the camshaft pins and the crank locking pin to do the cam belt tensioning, which is done at various points around the rotation of the crankshaft. You can probably see from this Lotus wheel, timing wheel. So a normal timing wheel's got all 360 degrees, and you can see the camshaft valve time opening and closings on there for inlet and exhaust. But here what we've got is just specific positions to test the tensioning on the left hand bank and right hand bank. So we're looking from the engine the other way, so this is actually the right hand bank, so we do the tensioning here when we're at the right position on here. So right hand bank there is 120 degrees after TDC, so we rotate the crank after to get that. And the left hand bank is here, so we do the cam belt tensioning here, and the left hand bank is at 80 degrees after top dead center. Right, so I've taken the crankshaft locking pin out, and also all 4 of the camshaft locking pins, and I've rotated the engine to 80 degrees ATDC after top dead center, which is where we do the left hand bank cam belt tensioning. So left hand bank is this, and now I can't show you doing this, but what we do is strum the timing to the belt in this location and measure it either with a very expensive clavis gauge or with some software on a smartphone which records and gives you the frequency, and when it's working much like a guitar tuner, so it's just listening to the frequency of the note and telling you what it is. So in this case it will report it in hertz, and we can compare that to what's specified and allow for the cam belt tension. I'll be changing these cam belts like I said, so then we'll go through the procedure of doing that and adjusting the cam belt tensioners here. Actually we could do this, we could do the right hand bank as well, so then we move the crank around to 120 degrees after top dead center. That's the right hand bank, so we then do the same procedure on the cam belt on the right hand bank, of course looking from the other side.